Okay, Juan, good afternoon. Thanks for making it out to today's webinar. So as you can see on your screen, I already have your project sort of modeled on SoilWorks. And what I'll do is I'll just sort of go step by step what you need to do in order to get your basic modeling and your analysis done. So I hope it's okay if I start now, just a little bit early. But if you have any questions at all, feel free to just type into the chat box. Or if you need help with anything, if you have questions that you want to save for later, what I'll do is we'll have just a question and answer session at the end of this demonstration. Okay. So as you can see, I already have your project sort of drawn onto the program. So what I did was I actually imported it using the import option. So let me show you how that's done. And as you can see, here's your file over here, and I imported it, and it was just immediately just sort of imported into the software itself. But when I first got your file, it had like several different layer sets, but I drew over it, and I created just one base set just for simplification. So as you can see, I've just sort of consolidated just the entire drawing into one base set, just so it'll be simpler for us. Okay. So now the first thing that we need to do, and just another thing to note before I move forward, when I got your drawing, the dimensions were very large, so I actually scaled down the drawing. So the dimensions of this particular project might be a little bit different. So let me show you the dimensions. So like the depth here for the footing is about 5 feet. So I'm not sure how it was for your project, but when I first got the file, the footing depth was over 50 feet. So I thought that was a bit large. So I just scaled down the entire drawing just to get, like, I guess, a more realistic model. But once again, we can discuss those specific details later on. Okay. So the first thing that we need to do once we have our model imported, or once we have our DWG file imported, is to create our surfacing. So what I'll do is I'll go to Geometry, and then I'll just go to Smart Surface. And using this feature, the program will just automatically separate our surfaces so that we can assign material and structural properties to them. Okay. So as you can see, within a mouse click, everything has been separated, and now I can, define, or I can assign material properties to these various structures and soil layers. So my next step will be to define my soil layers. And before I move forward, as you can see, I have all of my different smart surfaces separated now. So I had my base, which was just the drawing itself, and now these surfaces represent different surfaces in the drawing that I can assign properties to. Okay. So first, let's define our ground material properties. So if I go to this tab here, once again, it's just in the upper left corner after I click Geometry. As you can see, I've already defined our 4 different types of layers. Because I just received the drawing and I didn't receive any like soil layer information, I just assumed the layers. So what I did in order to assign these layers was I actually went to the database in the software. Okay. As you can see, the soil or the database is very in depth. And if I open this here, I have all these different rock types, and if I click on them, as you can see, I have different soil types along with their various soil parameters. Here's another one. So we have a very in-depth database that's there for you. And at the same time, if you want to make changes, you can just click on the data itself and make your necessary changes and then save them. And then these changes will be saved for future reference. So for this project, I just went to the very first option that was available. So this one here. And I selected weathered soil, weathered rock, the colluvial layer for the top layer, and then class 3 rock, as you can see. And then I just clicked Assign. And when I clicked Assign, all those layers just popped up in that part here. Now another thing that I'll need to do is I'll need to assign a material property for the structure itself. So what I'll do now is I'll just create that. So I'll make it an elastic ground property, and then I'll name it structure because that'll be assigned to the structure itself. Okay. So what I'll do actually, before I move forward with that, let me actually change the units. So right now we're in pounds and feet, but personally I like to work in kilonewtons and meters, just for the sake of simplicity, just because it's easier to input the values. I get more round numbers within the metric system. And if you ever need to make changes to your units, you can just turn to this over here, and all of your units will be changed automatically. Okay. So now what I'll do is I'll just go back to what I was doing. I'll make it a structure. I'll name it structure. And then it'll be an elastic ground property. Okay, so 20,000 kilonewtons per meter. Poisson's ratio, let's make it 0.25. And then unit weight and saturated weight, let's make these uniform. So let's make them both 25 kilonewtons per square meter. Okay. And then what I'll do is I'll just click add. And as you can see, structure is now added to the types of material properties that I could assign. Okay. And also, if you want to keep track through the work window, just go to the properties section, grab material properties. And as you can see, all of my properties are there for me to assign. So now that I have all of my properties defined, let's assign them to the various soil layers and structures. So first, let's choose the bottom layer, class 3 rock. This layer, weathered rock, weathered soil, and last, the colluvial layer. Okay, so now all of my soil properties have been assigned, and if I want to double check, I can just click on, the, there you go. I can click on the layers themselves to get the object information. There you go. And as you can see, it says class 3 rock, and it has like the surface number as well. Okay, and next I'll need to assign my structural properties to the structure itself. So I assumed obviously the footing is a structure, and I assumed this top layer here was like a concrete or a pavement of some kind, and then of course your wall. So obviously these structures have different properties. Say maybe example you have maybe some timber or some reinforced concrete. But just for the sake of simplicity, let's just assume that these all properties are uniform. So it'll be structure, the one that I just previously defined. So first I just need to select the structures themselves. Okay, so it'll be these three surfaces that'll have the structure property assigned to it. And I just drag and drop, and then they've been assigned. Okay, and next I noticed that you said the point of interest of the project was this pipe over here, that your clients want to make sure that this pipe will be okay once you install the footing. So in order to just get an accurate sort of analysis of the pipe, we also need to assign a structural property to it, because right now it's just a line. It doesn't have any sort of properties to be used in the analysis. So what I'll do is I'll go to geometry, or actually I'm sorry, model, and I'll go to structural property. Okay, so I don't have any structural properties defined yet, but I'll name this one pipe. It'll be a beam type, and then let's make it a rectangular shape. Okay, now we just need to define our sections here. So let's make the H section, or the height, 0.075, and let's make B, or the width, 0.1. Okay, and as you can see, the stiffness is calculated automatically, and if you want to check your material properties, because you can go over here and you can make your necessary changes. So for this one, let's just go with the properties that the database has selected for us. Okay, so before I move forward, just make sure to press add. That way you know it's listed, and then click close. Okay, and now we just need to assign the properties to the beam itself. So let's zoom all the way in here, and let's just select all of these curves. Okay, and then let's go to structural property. As you can see, pipe is listed. It's in blue because it hasn't been used yet, or it hasn't been assigned yet. And then just drag and drop. And as you can see, the sort of graphic display changes just to give you a better visual representation of what the pipe actually looks like, as well as to let you know that it's been assigned a structural property. So let's zoom out now. As you can see, most of our modeling is done. Now we just need to create our meshing and our boundary conditions. So I believe we discussed this in one of our previous webinars, but the Smart Mesh feature, with this feature, the SoilWorks can actually create the mesh for you automatically. So within a couple of mouse clicks, the best sort of mesh set will be created. But at the same time, if you want to manually create the mesh for whatever reason, these types of meshing are available to you, as well as auto meshing, which is more convenient, but at the same time you still have to select your surfaces, etc. But let's go with smart meshing because it's the most convenient, and obviously, and also it's important to note that this is a feature that's unique to SoilWorks. So right now, no other software programs or geotechnical software programs have this feature. So let's make it very fine mesh, and let's generate triangular elements. Okay. And as you can see, just within a couple of mouse clicks, all of our meshing has been created for our soil layers as well as our structure. Okay. So now that we have our meshing, next let's create our support conditions. So let's go all the way here. So under loads boundaries, just go to smart support and boundary set. Let's name it that. And then once again, this is another great feature of SoilWorks. Instead of having to manually, select your surfaces for your boundaries, you can just use this feature, click OK, and then all of your boundaries have been assigned. So once again, these are just two features, smart meshing and smart boundary conditions, which will help you save time just to increase your efficiency and to make it much easier for you just to create your models. Okay, and I believe you also included the water table information. So I believe the water table was under the second layer here. So let's create that as well. So go to Loads Boundaries, and then go to Water Level. Okay. So just type in water level, and let's select our curves. So it'll be this curve over here. So we just select it, press OK, and as you can see, our water level has been created. Okay, so now that we have our meshing and our boundary conditions, the next thing we need to do, just one thing to note, since I didn't receive any sort of information on any type of loading that'll be on this wall, we won't be inputting any types of loading. But say, for example, you're going to build something on top of this wall, or there'll be any kind of vertical loading in this area. What you can do is you can just use these the loading features just to input those. So say, for example, just for the sake of argument, say you had like a pressure load in this area over here. What you could do is you could select pressure load, load set, maybe type in, I don't know, let's say, for example, maybe you have some traffic over here. So let's put in vertical load. It'll be select element boundary curve, and then it'll be a uniform curve just in the normal direction. And then you could just go up and select the curve itself. So you'd have to go across, obviously, just selecting all these curves. So let's just say, I don't know, let's just say it's over here in this area. Then press OK. And then also make sure to type in your load value. So let's say 25 kilonewtons per square meter. Click OK. As you can see, your load is graphically displayed. But once again, and also keep in mind that you can have as many different sort of load sets and combinations as you'd like anywhere on the project, and it's very easy just to sort of click on your surfaces in order to assign them. But once again, just for this project, I didn't receive any particular information on any type of loading. So let's actually just get rid of that for now. Actually, okay. And then obviously self-weight, another important thing to note is that self-weight is actually calculated automatically by the program for you. So that's something that's very convenient. So instead of having to worry about self-weight, the program will just automatically take into account the self-weight of the ground itself as well as your structures. Okay. So now we're almost ready to run our analysis. The next thing we need to do is to define our analysis cases. So for this project, I'll assume it's a construction stage analysis. So what you'll want is sort of what your project site looks like before and after the construction of this wall. So what we'll do is we'll go to construction stage, and we'll name or we'll outline two different construction stages for you to use. So first, let's try initial. So this is before construction. And then we'll click add, and it'll be a nonlinear static analysis. So add. And then the second construction stage will be, let's just put freestanding wall. So this freestanding wall construction. There you go. So what this case will do is it'll analyze sort of the effects on your soil and your pipe after the freestanding wall has been constructed. So click add. As you can see, these two construction stages will be taken into account. So once we have our construction stages named, now we have to simply define the elements that will be taken into account during each analysis case. So next, let's go to define construction stage analysis. Okay. So as you can see, here are all your various mesh sets. And anything that says structure, since I assigned the structure ground material property to it, they've taken on the name structure. So structure, structure 1, structure 2, etc. So anything, so for example, the surface here, as well as your foundation or footing with your wall, they all have the structure assigned to it. But everything else that has been assigned, for example, weathered rock, class 3 rock, those have been named according to the properties that you assigned to it. So obviously in the initial construction stage, none of your structures will be present. So what you need to do is you just need to drag and drop anything that isn't a structure into the mesh set property. So your base, that'll be included. as well as weathered rock and class 3 rock. Okay, and then obviously your pipe. So I assume the pipe is there before construction, so we'll drag and drop that there as well. Okay, perfect. And then the next thing you need to do is just include your boundary set as well as the self-weight. Okay, so all of these things will be present obviously before construction. So once we're set with this construction stage, we just click apply. And then it's also an important thing to note that whenever you make a command or you specify or create anything new, make sure that it's been generated in this command line here. Otherwise, it hasn't been generated, and you'll need to sort of recreate it. So that's just another important thing to note. Okay, so the next step, we're going to define our next construction stage, which is after the wall has been constructed. So obviously now we have to include all of your structures. So for example, all of your structures that have been defined, you can just click on all of them. So just go down the list here, and then structure 13, and then drag and drop them into the activated at current stage. So another important thing to remember is that once you activate something in a previous stage, you don't have to reactivate it. This activated at current stage is simply for things that will be activated presently. It doesn't apply to things that need to be sort of reactivated again. So for example, you already activated your soil layers, your base, your boundary sets, and your load sets. So you don't need to reactivate these in this stage. But if you want to deactivate anything, you would need to drag and drop from the input data to the deactivated at current stage. That's for more, I guess, complex analysis, and we can maybe discuss those types of projects later. Okay. So now that I have all of my structural properties inputted for my post-construction, I can just click apply, and then it's been generated. Okay. So click close. As you can see, I have all my construction stages set, and if I can turn to the work window here, I have all my construction stages, and next I just need my analysis case. So this is empty, and I just need to create one before I can finally perform my analysis. So I just go to the Analysis and Design tab, go to Analysis Case now, and we'll click Add. So we'll name this, I guess, Settlement Analysis. And make sure to specify that it's construction stage analysis. So as you can see, when I make it a construction stage analysis method, all of these areas gray out. So the reason this happens is because I've already defined all of my element stages in my previous step, and the one I just showed you where I was dragging and dropping all the elements. So whenever you do that, just make sure that all of your stages are set beforehand. So for example, if I were to do a static line linear analysis, I'd need to define all of my sets because it would be just sort of an analysis for an individual case. But since I've already defined everything in my construction stage analysis, I don't really need to worry about that now. Anyway, so now that I have that set, I just click apply. Okay, and now I have my settlement analysis, and it's specified that the method used is construction stage analysis. So it'll take each of those stages and create a file for each, or an output for each. Oops, close. Close. Okay. So it looks like we're ready for our analysis. So the next step obviously would be go to Analysis and Design, and then click on the Analysis tab. Okay. And I only have one analysis case, but just keep in mind that if you have maybe multiple cases that you want to analyze or different methods that you want to use, you could have as many analysis cases listed here in this box, and the program will analyze all of them simultaneously and give you like a readout that has your analysis for all those different cases. But once again, this is a simpler project, so let's just stick to one case. And then perform analysis. Okay, so it'll just take the program a few moments to perform the analysis. So because this is a finite element analysis, these take a little longer. But as you can see, it's already done. Okay, so let's take a look at our post-processing. So as you can see, the work tree has changed to the results tree. Which means instead of having a readout of all the work that you've created, this will just have a readout of all of the results. So as you can see, under settlement analysis, which is the only stage or the only analysis case that I specified, I have initial step and then freestanding wall construction stage, last step. So before and after construction. So let's take a look at our project before construction took place. So let's take a look at, I guess, ground element stresses. Okay. So as you can see, there isn't really much to, I guess, look at here. Let's take a look at displacement, actually. So as you can see, there's absolutely no displacement because there's nothing being applied to the project on site. And as you can see, let's go to, I guess, ground element or ground element strains. Oh, actually, I think I have one of the layers turned off. So let's actually go into pre-processing and let's turn that layer on. Okay, so let me just drag and drop it over. Okay, there we go. So now I have all of my sort of layers on, and now I can get a better look at what's going on with my pipe here. So let's zoom in here. So suppose this is your sort of area of interest. And as you can see, nothing is really happening because this is before construction. So everything's fine with the pipe. So what you want to focus on, I guess, is what happens after construction or after your free wall is generated or constructed. So let's go to that. So as you can see, nothing's really happening too much with the pipe. But I guess what you'd want would be to see the displacement or the vertical displacement that was caused by your pipe, your wall here. So as you can see, according to this analysis, your pipe is fine. It's really the ground just around these areas that will be changed. And if you go to the legend here, it shows the displacement, and this is in meters. So as you can see, like the further away the pipe is from, the further away you get from the base here, the less sort of displacement is made on the soil. But once again, this could change drastically depending if you have different soil layer properties out there in your site in California, as well as if you have any kind of additional loadings being placed on either side of the wall. But just for this case in particular, the pipe is virtually unaffected by the construction of your wall. And then also you have your total displacement and your rotational displacement, horizontal displacement, other things that might be of interest to you. And then you have all of your strains and your shear strains, etc. And also your beam element stresses. So say for example, you want to close into your pipe here and see like the effects on the beam. You just click on that, and you can refer to your table here to see your different stresses. So because of the finite element analysis that was done, you have a very in-depth analysis full of various results that could prove useful to your clients, or that might be of interest to your clients that they want included into the report. And also you have your axial, your shear, and your moment for your beam or for your pipe here. And then you can also, if you have any other kind of structures in the area, you could assign the structural properties to them, and then the beam diagrams will all be sort of generated for those various elements. Okay. And then just to wrap up, let me just show you a couple of result options that are available to you. So let's go back, I guess, to pre-construction here. Or actually, I guess since it would be more of interest to go to your displacement here, particularly total displacement. So let's go to your results section. Let's see. So result value. So you can have your minimum and your maximum. So these are of most interest in any project, your maximum and your min displacement. So if you click on that, it'll just be displayed directly onto the work window. Let's see what other, also band lines. So if you want more definition in your bands, you can click on that to get, I guess, a more detailed sort of contour graph. Vectors sort of shows the direction of your displacement. And also, the length of the vector lines sort of correspond to the depth of the displacement. So as you can see, as you go further away from your footing here, the displacement is smaller, and the vector lines sort of show that graphically. Okay, you can turn that off. And then here's another great option. So result tag. So say for example you want to click directly on the contour graph itself and see your results, or get your maximum and your minimum. The tag will actually show up directly over it. You get your minimum as well, and then you can just clear it. Okay, and then your absolute values as well. Perfect. So once again, those are just sort of options, just to give you a wider range of options as far as how you want to display your results. And there are more of them here, but I think you get the basic sort of, I guess, gist of the of this feature here. So anyway, I guess that sort of wraps it up for my demonstration. I hope I sort of addressed any sort of concerns you have. And at this point, what I'll do is I'll just open it up to maybe any questions you have. So right now, I guess if you have a microphone in your office, you can just speak into it, and I should be able to hear you. So let me just unmute you for a second. Okay, perfect. So once again, if you have a microphone, just speak into it, and I should be able to hear you. Okay, Juan, so I just got your message. What I'll do is I have my cell phone right here, and I'll give your office a call. So you can expect a phone call from me in just a minute or two, okay?